This is fantastic. Thanks for coming. While those people are getting settled down, yeah, hopefully you're all here to talk about chaos, or hear me talk about chaos. If you're not, I don't know what you've been staring at for the past 10 minutes, but we're going to do that. So last night I was talking with a few folks, and they were, they said it a little matter-of-factly, but I think they were lamenting the fact that like political season is coming up on us, and y'all are just going to get inundated with a bunch of desperate candidates like trying to kiss your babies and do the handshaking and everything else. This isn't meant to be political, but I love this quote from Barack Obama. And it says that you can't let your failures define you, right? You have to learn from them. You have to let your failures teach you. So I love this quote because it really defines what chaos engineering is all about, right? It's less about the breaking things and all the automation, and it's more about how we can learn about things, how we can learn from our failures, how we can take our failures and use them to make us better. Now, Brock said a whole bunch of other stuff. He talked about hope a lot, and I like this quote about hope. This is Corey Bertram. He's the Senior VP of Infrastructure and SRE at Datadog, and he says that hope is not a strategy, right? You can't just hope that your systems stay up, hope that they survive the next outage, hope that if you move to the cloud that AWS or Amazon, Azure, Google, anybody out there is covering your back, even though there's SLAs, right? You got to take care of it yourself. You have to have strategies. And the reason that Corey said this is Corey used to work at Netflix. Corey was part of the first team that started to implement a lot of that resilience engineering. So it's really interesting. Who here has heard of Chaos Monkey? I think that's most everybody, right? Who here has heard that Chaos Monkey was this program that would randomly blow your shit up and then leave it up to you, and hopefully you survived and it trained you to be better, right? I think that's most of us have heard that story. Unfortunately, that's not quite true. So actually, if you go back, it's now on Medium. It used to be on their internal blog. But the engineering blog for Netflix, and unfortunately this is probably small for those in the back, I do have my slides online, so I'll give that link to you later. But if you read back through that original blog post, it said a lot about how to do chaos engineering, and it told a lot about their story. See, the whole point behind this was actually Netflix was moving from their own on-prem systems up into the cloud. And they realized things about the cloud in those early days, that the cloud wasn't reliable. Like, the point of moving to the cloud isn't that it's reliable. The point of moving to the cloud is that you have all of these resources that you can spin up with an API, right? And so if you have that ability, then it's not so much about keeping things up all the time as it's how to leverage that, right? How can I leverage if my systems go down, if my systems come under attack, if my system sees spikes in traffic, well, how can I utilize those APIs, spin up more resources to help? And they realized that as part of this, in order to understand failure, you have to fail all the time, right? So if you're failing all the time, you can now start to test out a lot of these things. So that led them to create Chaos Monkey. And so Chaos Monkey was this tool that they decided to use. So I've learned a lot from Corey in talking with him. He's implemented a lot of this over at Datadog. So who am I? Well, I didn't work at Netflix. I'm Jason. I'm a technical evangelist at Datadog. Essentially, that means that I get to learn a lot about technology. I get to introspect our practices at Datadog because we operate at a very, very large scale. And then I get to talk to all of y'all, hear what your problems are, hear what you're into, and then provide some advice, whether or not that's monitoring, which is what Datadog does, or not. Other things about me, I travel a lot. I collect whiskey. Unfortunately, I'm on antibiotics, so I haven't been able to drink any recently. And I do have a hat that actually looks like that because I'm like super addicted to Pokemon Go. So Buddy got me a hat that's a Magikarp that I actually sometimes wear. If you play Pokemon Go, talk to me later. Also, I have Pokemon Kubernetes stickers. My contact also was on that slide, so if at any point you're like, I have a question, especially after the conference, you're like, oh, I was remembering he was talking about this thing, and I don't remember what it was, or you want to dive into something, feel free to hit me up. This is my job, is to, again, talk to you and help you resolve your issues. So a little bit about Datadog, because they do pay my salary. They're a SaaS-based monitoring platform or observability platform. That means we handle your metrics from your applications, your infrastructure. We handle your traces, distributed tracing, so we can see as requests come into your system, you can trace that across to other systems. So if you're doing any sort of services or microservices, we can also do APM, so we'll start to look at your code. What functions were called, what methods were called, where are you seeing bottlenecks? We do log analytics, so we'll ingest all of your logs, help you find the patterns, help you identify issues there. We just rolled out a synthetics product, so essentially you can click around on a website, record that, and then have that replayed as a recording from around the world to essentially replicate what your users are seeing. We are hiring as well, so if after this you're like, my company will never do that chaos thing and I really want to do it, come talk to me too. So to get back to what Netflix was talking about, if you actually were to read that blog post, and again, I apologize to those in the back if you can't read it, but when they were talking about running chaos, they said this, that by running Chaos Monkey in the middle of business day, so it wasn't just completely random, in a carefully monitored environment, which is crucial, right? It wasn't just, surprise, I took down your systems, who knows how you found out about it other than complaining customers. And importantly, engineers standing by to help resolve that, right? So with all of these three characteristics, then the idea is to learn the lessons about the weaknesses in their systems. So hopefully, when these same occurrences happened, they were able to build systems to resolve them, or at least have a plan so that it didn't wake them up. So if there's one lesson, one single lesson that you get from this talk, do not be a jerk. If you're rolling out Chaos Monkey or some sort of other system that breaks things, and you're doing it in the middle of the night, and you don't have the right monitoring tools, and there's nobody there, and you're just surprise attack on your colleagues, then you're a jerk. So don't be a jerk, right? So how do we do it at Datadog? Well, at Datadog, we run game days. Game days, just like any game, football match, soccer match, baseball game, it's there to have fun. And in order to have fun, you need some rules, right? I was talking to some folks in Italy, which is why this is the Italian soccer team, and I was mentioning to them, there are strict rules around soccer, right? I can't pick up the ball with my hands unless I'm the goalie, and there's other things. Because if you don't have those rules, well, then I'd run up to you and punch you in the face and try to grab the ball and then go run it to the other side of the field, and it'd be rugby at that point, and I don't understand rugby. So game days, what are the rules? Well, like any game, or many games, it's time bound, right? So, football games have times, basketball games have times, soccer has times. In soccer, it's a 90-minute game, right? And you want to time bind it because when there's that box around it, it means that it's not going to go on all day, right? Number one, you want this because, well, if it's going to go on all day, then if I'm busy working on stuff, I'm never going to actually do this. And number two, if you're trying to sell your manager on this, and he's like, well, we got to roll out this new feature. How long is it going to take? And you're like, I don't know, all day, maybe all week. You're never going to get permission to do it, right? So 90 minutes is what we cap it at. 90 minutes is nice and small. It's easily digestible. It's easy to sell as saying, hey, I'm just going to take an hour and a half, middle of the afternoon, and do this. How do we break that down? Well, the 90 minutes, the first 30 minutes of that is spent in planning. Again, you want to keep this time boxed because nobody wants to spend all day planning. If I have to write up reports and talk to a bunch of people, and it takes me weeks to get this out and actually run this, well, that's not fun, and I'm not going to do it. So we spend 30 minutes in planning. We spend 50 minutes, which is the bulk of the time, actually playing the game, breaking our systems, seeing what happens, getting creative in our engineering. And then we spend a final 10 minutes. That final 10 minutes is just for reporting. Again, we don't want this to last too long because nobody likes writing reports, right? Have you filed your TPS reports? No. Right, 10 minutes. So 10 minutes, really short. Gather up those notes, send them off in an email, be done with it, right? Really simple. All games have teams. So what are our teams? We keep these nice and small, because again, if you're trying to coordinate a bunch of people, that takes a ton of time. You're never going to get that done. So we start with just 2 people. The first is going to be that subject matter expert. This is going to be the lead developer for that service team, or the lead engineer for that infrastructure team. And then they're going to partner up with somebody from our SRE team. So the SRE is there. They know a lot about systems. They know about how to keep systems resilient. They're going to be there to provide that advice. But the subject matter expert really knows about that system, whether it's an application, whether it's infrastructure. They generally know how things are going to react. They know how to resolve them if things go wrong. Sometimes, just sometimes, we have a third person. And more, I'm trying to encourage people to always do this. But that third person is going to be a junior engineer or a junior developer. And the reason this is so important is because subject matter expert knows the history behind the applications. They know why something was written really weird. They know what technical debt is there, right? But those junior engineers have that fresh perspective. So when something goes down and the subject matter expert says, oh yeah, don't worry about that. Well, why? Why shouldn't I worry about that? Tell me, or when the subject matter expert says, yeah, this thing's a little funky. Well, why? Like, explain that to me. Number one, it gives you that extra insight. Number two, you're helping to train those junior engineers, right? You're starting to do a little bit of mentorship. So you get that benefit on both sides. So I did mention that the before, the planning, is 30 minutes. What do we do? Well, number one, you schedule it. And again, it's just 90 minutes, so it's relatively easy to schedule. Things, though, that I should advise you, don't do it at the end of a day, because should something go wrong, you end up staying later, you really don't want to do that. So try to plan it for more in the middle of the day. Oftentimes, mid-morning works really great. After you've gotten your coffee, after you've answered emails, started to get settled in, it's the perfect time. Part 2 of the planning, pick your tests. And here's where I advise to keep them simple. Don't think of some crazy convoluted scenario with what happens if this server goes down and simultaneously that replicated shard goes down, or simultaneously DNS goes out and AWS, someone fat fingers and takes down Amazon East. And no, just keep it really simple. Pick one of your services, start to understand what happens when, for example, it loses a critical dependency, right? Make it easy. Again, you've only got 50 minutes to play with this, so come up with 2 or 3 tests that you want to run. And I'll talk about some of the tests that we run in a bit. The next thing is to write down what you expect. We're treating this like a scientific experiment. So what's your hypothesis? If I kill DNS, what happens to my services? Can they actually talk to any of the other services or dependencies? If I take down a server, what's going to happen? And the thing about this is it's your hypothesis. It doesn't have to be that, oh, my service survives a nuclear attack. Could be as simple as, hey, if I unplug this server, it means that service goes down, right? But then along with that comes the other things of, well, if I unplug this server and the service goes down, do I get proper alerting on that? If I unplug this service and that service goes down, what happens to my other services that rely on that, right? Do I get alerts from those? What's my end user going to see? What sort of limited application performance can they see? So write down as much as you can of what you expect. The other thing that you need to write down is your plan B. So I take down a service. Okay, I understand that that service is no longer there. It might affect other ones. What if those other services have other services relying on them? Am I going to see a cascading effect? Well, I may not. I don't plan to. I don't intend for this to happen. But I need that plan B. What am I going to do if that happens? If everything goes horribly wrong, even if you're running this in staging, you take out everything. Now all of engineering is just sitting around because they can't do development. What are you going to do? So always have a plan B. And then finally, most importantly, you share this document. So at Datadog, this goes out engineering-wide. Everybody in the engineering side of the organization, which at this point is nearing 500 people, they all get a copy of this email. Why? Because they might be affected, right? They might need to know about your plan B. They might need to know why a cascading effect has affected their service, why they're seeing additional latency. And I suggest that if you're in a smaller organization, if you're in an organization where you have a lot of salespeople that are out there, or customer account representatives who are dealing with your customers, let them know as well, right? Because if you see a cascading effect and suddenly your customers are angry, well, it's good for that first line of defense to know about it. So if that's going to be their account reps, that's going to be the first person they talk to. And it's good for them to know, well, hey, we're trying some resilient stuff. We're trying to make things better for you. Unfortunately, things got out of hand. Here's why. We're taking care of it. So that's the before. The during. So again, this is where the bulk of your time is spent, 50 minutes. How do we do it during the actual game day? So we actually, before we do this, we do have a process. We don't start directly in production. Just like any other code, you should never start directly in production, even with chaos engineering. So we started in staging, because we do have a replicated environment. So you see what happens in staging. If things look good there, then we roll it out into production during off-peak hours. And then if things look good there, we run it again in production during main hours. So just like any sort of code, you want to stage that. But the first thing that we do is you want to announce this, right? Again, a lot of this is about communication. So we run everything in Slack. You should do all of your announcements in whatever sort of chat ops group chat tool you're using, because you want a record of this, right? If I go around the office and say, hey, I'm starting this test, and somebody decided that they were taking a late lunch because they were busy during the middle of the day, they don't know, you've lost that information. So you want a place that everyone can look. Similarly, you want to maintain that discussion in whatever group chat you've got, whether that's, again, Slack, Jira, whatever you've got, because you want that transcript, right? You want the ability to see what people were talking about. It's very easy and it's very common when you're in an office to just turn to the side and say what you're doing, talk about it with other people. But by having to write it down, having it in chat, means you have an instant dialogue. I no longer have to remember when I'm writing up those notes later, what did we say about this? What did I think was happening? What were those symptoms I was seeing in the system? You've got those already right there in Slack. Also, if things go horribly wrong, it means that other people can take a peek at what you were talking about, what you were seeing, so that they can sort of eavesdrop on that dialogue. The other thing that we do is we monitor for outages during this period, right? So we do this in two ways. Obviously, Datadog, we are a monitoring platform, so you open up all the dashboards. But we also monitor in Slack. So similarly to all of this, whenever someone declares an incident, or if they declare an outage, for us that happens in Slack. Partly because we have a remote team, so there are people who aren't in the office and wouldn't hear if you were actually to say it out loud. But also, again, because we have the ability to look back at things, right? If I'm starting to see something during my game day, and it happens to have that same timestamp as someone talking about something in an outage channel, well, then there's a correlation there, right? I don't have to match those up later. And then finally, you get to the bulk of it. You run your experiment, right? You take those tests that you defined, take a look at what your notes were and what your hypothesis is. You start to run it, and you take notes as you do. Pretty simple. Afterward, this is that 10-minute period afterward, right? So we're going to create cards. All those things that we saw that we were writing down in Slack of like, oh yeah, this thing didn't work quite how we thought. Maybe we should update that config. Maybe we should build this new system. Make those into whatever tickets you use. If that's Trello, if that's Jira, track those. Otherwise, they'll never get done, right? We've seen that before when you run a post-mortem or you're doing something else and someone's like, hey, we should do this. Someone forgets to write a card. Does it get done? No. So the other thing, you write down your summary and key lessons. So write down what you saw. What did we see? Did it match what we thought would happen? If it didn't, what didn't, right? Hopefully you've had some time in that 50 minutes to explore it. so you can write up those notes and those details. And then again, you email this out. So we email this out to all of engineering. At this point, we run anywhere from 4 to 6 game days a week. So we try to not have them overlap. So it's usually about 1 a day. So at this point, we don't email them directly all the time. Usually we bundle them up and we have a weekly report because we have a team that sort of manages the scheduling of game days. But if you're only running 1 a week, if you're starting to dip your toe into this, email it out. Ensure that everybody has that information. And the most important part of the after section is you celebrate. At Datadog, we love to celebrate everything. I got an email a couple weeks ago that literally all the email said was, champagne toast in the kitchen. No context. It was just, we're celebrating. That one turned out to be that we'd gone over 1,000 employees, but we literally like to celebrate anything and everything. And it's a good thing for you to adopt in your culture too. I think it follows DevOps principles of celebrating. In this case, you're celebrating that you learned, right? Let's say you roll out a game day and you were in staging and you just took down everything. And literally everybody for 2 hours was just sitting around because they couldn't deploy to staging, they couldn't get work done. Still, round everybody up, head to the kitchen or head to your local bar afterward, have a beer, whatever beverage of choice, celebrate that, right? Not that you took everything down, but that you learned something very important, right? You could have very well learned that you had some cascading critical error, and it could have been in production. It could have been on a Friday night or in the middle of the night on a weekend. You just diverted that, right? You did it in a very controlled environment. Yeah, it wasn't expected, but you learned a lot. Similarly, everything could have gone perfectly, right? Everything in your hypothesis, you went it all according to plan. You got all the proper alerts for it. That's fantastic, man. You built a great system. Celebrate that. So whatever you do, celebrate your learnings, celebrate your wins. So what do our tests look like? Well, our chaos team has decided to do zero indexing, which makes sharing this slide a little awkward sometimes. But the first test, the level 0, is to terminate the service, right? So they start with terminating the service. This could be as easy as if you have a server, SSH to it, run PS, find out that process ID, kill-9 it. What happens, right? Does it restart? Does it not restart? If it does restart, does it need anything? Does it need some manual intervention? Also at this level, the other test that they run is to block access to one critical dependency, right? So if I've got a simple service that uses a data store, runs Postgres on the back end, what happens if it can't write to Postgres? Right? Simply cut it off. You can do that by going into using IP tables and just like redirect that traffic to somewhere else. You could, if you have access to that data store, you can turn it off, obviously. There's a lot of ways that you can do this, but keep things simple, right? From there, it graduates up. We block access to all dependencies, right? So again, we can use IP tables and just block all of the network connections. So now our service is just sitting there. What happens to our service? And again, reminder, this doesn't mean that your service has to survive. God, if it survives that, you're a fantastic engineer. By the way, did I mention we're hiring? No, but you block all the critical dependencies. Well, hopefully you should get some sort of alert, right? Your monitoring system should say something. You should have sirens and alarms going off like nothing. Yeah, I mean, so really, build systems that have that right monitoring. Doesn't have to survive. It just has to behave in the ways that you expect so that you get that proper alerting. Level 2 is where we terminate the host, right? So what happens if that node dies, or that VM dies, or that physical machine dies? This reminds me of ages ago, I used to be an IT guy, like actual physical IT guy, because I'm much older than I look. We'd bought this massive UPS for our servers. And my buddy Todd goes and plugs it in, and he's like, this thing will last, like he did the calculation, and apparently it would last over the weekend, which I don't know why he got something so big. So it's like, cool, we have to test it. So he plugs the server into the UPS, plugs the UPS in the wall, runs back to the server, pulls the power plug out of the back of the server. Like, that's not how UPSs work. Obviously, that didn't survive. We tested it properly. If you pull the UPS out of the wall when it's turned on, that actually did work. But yeah, don't pull power plugs directly out of your servers. Level 3 is where we degrade the environment. So we'll do things here like introducing network jitter, introducing disk issues, right? Like, what if you can't write to disks? Introducing latency. We also, at this point, want to ensure that everything has complete monitoring on it. So we have monitors and alerts on what's called the 4 golden signals. And the 4 golden signals comes out of the Google SRE book that was published a number of years back. But the 4 golden signals, I shorten it to LETS. LETS is an acronym for latency, errors, traffic, and saturation. So you want to alert on latency, right? If your systems are starting to get slow, if your service is starting to get slow, whether that's customer facing and they're seeing a lot of lag, or whether you're providing data to another system, you want to measure that lag. If that's increasing, then that's a bad thing. Errors, you want to track not only your error rates and how many errors you're seeing, but you want to track what types of errors you're seeing, right? So take a look at that. Traffic is essentially how much traffic is coming to your system, how much traffic are you generating to dependencies. Right? Traffic coming into your system could be good, right? It could mean that customers are very happy and they're using the new application and everything's great. Could be really bad though, right? It could mean that someone wrote something and now you're actually seeing increased hits on services. Or in a lot of cases, when you're running chaos tests, if you're introducing things like jitter, it could be retries, right? So you're starting to get a lot more retries. That could potentially lead to other cascading failures as you start to hammer other systems. And similarly, saturation. So saturation, how are you using the resources that are available to you? So if I pull the plug on something, for example, if I have multiple replicas of something and I pull the plug on one of them, do I see increased saturation of resources across the other replicas? So you want to take a note of these. The great thing is, at this point, this is graduation day. So up until this point at Datadog, if you write a service, you are responsible for it. You own it. That means you're on call for it. The cool thing is, when you pass this, it means you've got all the monitoring. It means that you've got good alerting with proper documentation on what to do if there's an outage. You've got everything set up so that the SRE team can take over. So you get to graduate at this point. If you're a service owner, congrats, you can now share on-call with our SRE team, right? We don't like that thing that a lot of companies do where SRE team gets a bunch of stuff that they're supposed to maintain, they're supposed to keep it reliable, and they have no idea what it is, right? How many people are in that situation? Yeah, I see. There's a bunch of people that are like, I don't want to raise my hand, but that's me, and that's awful. Yeah. So this is what you're aiming for with all of your teams, especially your service teams, your developers. Getting all of that monitoring in place, getting to this level where they can at least understand what happens in a degraded environment. And again, it doesn't have to survive, but it has to have all of that alerting and that monitoring and written down playbooks of what happens or what to do when things go wrong. From here, level 4 is where we spike traffic. So starting to get a little bit more difficult, but essentially what happens if you DOS yourself, right? Can you survive that? Do you have built-in circuit breaking that will realize that? Do you have a WAF out front that realizes, hey, I'm under attack, let's cut this off? Or if you run things like data pipelines, can you actually ingest all of those jobs and queue them up and then process them asynchronously? So you have to start thinking about these things as you build resilient systems. And then finally, level 5, nuclear war type event. So essentially, terminate a region or a cloud. And I do have to admit, not all of Datadog has gotten here. Actually, very few services in Datadog can do this. But it's the goal, right? The goal is what happens if we're running in AWS and AWS goes completely down. right? Jeff Bezos goes crazy and he sells the company and fires everybody, right? Like, can I migrate to Google? Can I migrate to Microsoft? So that's the idea. Again, we haven't gotten there with everything yet, but that's the goal. So lots of information there. Who wants to run an experiment? Yeah? All right. Let's do this. So I've got a website here. Hopefully you can see in the back. It's just WordPress because I figure everybody's familiar with WordPress. Who's not familiar with WordPress? You're not familiar with WordPress? Wow, you're a brave soul for admitting that. All right, for all of those who aren't familiar with WordPress and were much more shy, WordPress is a basic LAMP stack application. So it's a PHP CMS, allows people to blog. So it's running PHP on the front end. It's running MySQL as a back-end data store. I've currently got it running in Kubernetes on my local machine. So I can do things like kubectl get service, right? So I've got 3 services here. One is Kubernetes because Kubernetes runs Kubernetes. If you didn't know that, that's a fun fact. But then there's WordPress, so that's actually my web application. And then I've got WordPress MySQL, so that's the database that's running it, right? Pretty simple. And so, yeah, it just looks like that. I can refresh it, comes back. So let's do a chaos test. Like I said, first step is planning, right? So I don't have 10 minutes to kill on this, so we're going to do this really quickly. Step 1 in planning, scheduling it. Well, congrats, we're doing it now. We're going to choose tests. Well, let's kill MySQL, right? MySQL is essentially the underpinning of WordPress. It holds all the data. So, interactive time. What do we expect to happen? Someone shout stuff out. Error messages. Can you be more specific? User-facing error messages. Cool. Anything else? Sorry? Mad strings. Bad strings. What do you mean by bad strings? It'll affect, yep. So it'll attempt to fetch data that isn't there. Cool. Anything else? Anybody else? I thought I saw a hand back here. Someone thought they were going to say something. You expected? What sort of expected result? Yeah, so you're expecting that it should understand that it's missing a data store and then do something else, right? Maybe aside from just a error screen, it actually shows like database unavailable. Cool. So I'm going to say catch the error and show a reasonable alternative. Yeah, that's cool. What about monitoring, right? Yeah, so monitoring, I should receive some sort of alert that like MySQL is gone, right? So automated alert, alert that MySQL is down. And then hopefully along with that, like my alert has some sort of useful playbook, right? That tells me not only that it's down, but what to do about it. Cool. So my plan B, what if things go horribly wrong? Well, it's on my laptop, so I'm not going to take down production. But if this talk goes horribly wrong, like I can't recover from this, it is afternoon, and so I'm going to say that we should all just head out of here and get a beer. Yeah, that'll be fantastic. So step 5, I'm going to share this. This is all available. So you'll see the empty version right now, but I've got a GitHub gist. So I'll show you that link later once I save all of this. Cool. That is plus experiment notes, lessons learned. I have these in the wrong order. Huh. Let's quickly fix this. All right, so we're going to run our experiment. Again, I've got the website here. So Kubernetes, for those who aren't familiar, there are things called services, which provide the user sort of facing endpoints. And then Kubernetes has things called pods. And pods are essentially like the servers, the containers that are running things. So I can see that I've got WordPress here with a unique ID, and I've got WordPress MySQL here. So cool. Tests on killing this. Well, I could do something like deleting this pod, which is essentially like killing MySQL. So what do we expect when this happens? Any Kubernetes people? Yeah, it's going to spin up another one. But let's see if we can actually catch this. So I'm going to delete that and quickly try to jump back here. Is that actually going to work? Nope, it's still up. This is why I love Kubernetes though, right? So if I kubectl get pods here, let's just, right? Sweet, 23 seconds ago. That was, probably did it while I was like yabbering. But cool, so that restarted. Everything seems to be working. Cool. It was so fast that like really nothing happened. Which is great though, right? So I'm gonna make a note of that. So I'll just say we killed the MySQL pod and it respawned. Right, and it respawned faster than we could detect. Cool. What are some other ways that we can kill this? Well, I can actually kill the deployment. And the deployment, for those, again, who don't know Kubernetes, deployment is essentially my definition on the types of pods to run, right? So it's my definition on what I want to run, how many replicas. So I'm going to just delete that. Deploy. Cool. So it says it deleted it. Hopefully you in the back can see that. If I get pods, it is now gone. Right? So I just have my WordPress. I've got a Datadog agent running there. So now MySQL is completely gone. So we're going to refresh this. Hey, we got an error message. Cool. So that seems pretty close to what we said before, right? I think someone down here was the one that said we should see an error message. So we'll make a note of that, right? You deleted the deployment and got the error message. Cool. Other things that we can note about this is we didn't get like a pretty page. There's actually like a dberror.php that you can add to WordPress that would do that. So that should be one of those things that we fix, right? We noted that we got an ugly error page. So let's say that we should create an alternate page for when the DB is down, right? Super simple. Everyone's still following? Cool. Well, what about my alerting? If I flip over here, oh, hey, I got an email 2 minutes ago, and it says, which is pretty small, bump that up for some folks. It says, triggered, MySQL was killed. MySQL is killed. If this was not intentional, please verify the Kubernetes deployment. Check the Kubernetes dashboard. Cool, so I'll click that. And that should load up a dashboard. Everything looks okay. Kubelet is up. Daemon set's running. 6 pods desired, 6 available. So that means that everything's running within spec. So it's not a Kubernetes issue. What else does it say? Well, it says check our team documentation. Doesn't actually have a link to that. So things we should fix. Let's link to team docs. And then it says to restart MySQL, ensure you have the latest YAML files, then run kubectl apply f MySQL. All right, cool. I'm going to copy that and actually test that out. That probably won't run from there because that's not where my files are. Sweet. So that applied for those in the back because it's lower down on the screen. It says that the deployment was created. So let me clear that just to get back to the top. And it looks like my MySQL is running again, 13 seconds. And if I go back to the website, reload it. Cool, everything's back. Cool, so things pretty much worked as we expected. That's awesome. So I'm going to make a note of that real quick. I'm going to say that we got an alert, which was awesome. And we also, we reapplied the deployment, and MySQL restarted just fine. Cool. Awesome. So experiment run. Things pretty much went as we expected, which is great. Congrats. So what do we do after this? Well, we write up our lessons learned, right? So again, this is the part that should just take 10 minutes. So really the nice thing about this is if you're taking notes while you do a game day, while you're exploring and having fun, simply just copy this, right? So I'm going to copy that as my summary. I could clean that up a bit. I'm going to take these and make JIRA tickets from these, right? And then we share this and we celebrate. Really simple, not too complex. Awesome. So let's jump back into this. So just to review, right? There's a lot of information in these slides. Again, I'll share those, but the number one rule is to share. When you're planning, write down that information, share that out. When you're getting ready to start your game day, hop into Slack or HipChat or whatever you're using, share that. Let people know that you're running the game day, monitor that so that you're sharing that information, write up that report afterward. Again, could be as simple as just copy pasting it. Hopefully if you've taken good notes, it's that easy. Share that. Takeaway number 2 is to plan. Write out that plan of what you expect. Come up with those hypotheses. And then write out that plan B. What if things go wrong? And then finally, most importantly, have fun with it, right? Explore your systems. Learn about your systems, especially if you're starting to get into microservices and stuff. Things act in really bizarre ways when you split them out into a million different pieces. So have fun and celebrate. A few additional resources. Number 1, you don't need fancy tools. Chaos Monkey's cool. It's open source. It's also very, very opinionated. Use the tools that are available to you. Systemctl, Kill-9, IP tables. You've got a lot of this stuff built in, right? If you're on a Windows system, you can open up your process manager, your task manager. You can kill things pretty easily. A few other tools, though, that we use at Datadog. One's called Comcast. Comcast makes your network really shitty. I don't know why it's named Comcast. So Comcast is a great tool, though. It allows you to introduce network jitter, allows you to drop packets, do all sorts of cool stuff with your networking stack. The other tool that we use is called Vegeta. Apparently Vegeta is named after some anime character, but Vegeta is essentially a good way to DDoS yourself. So if you've ever used Apache Bench, it's like that, but on steroids. So you can launch a ton of attacks. It's written in Go, so it's very fast. And the other cool thing about it, though, is it'll generate reports off of those. So you can feed it back in, it'll generate some nice charts and graphs for you to see things like latency and how your systems respond. I use Kubernetes in this talk. I'm also a huge fan of Istio. Istio is a service mesh that sits on top of Kubernetes. The cool thing about Istio is it controls the networking for all of your Kubernetes services, so you're able to inject faults. So you can, rather than taking down MySQL here, I could have just with Istio said, hey, always return a 500 error, and it would do that. A few other resources, Gremlin. Some great friends of mine work at Gremlin. They have a fantastic tool. It's founded by one of the guys that helped create Chaos Monkey. So it's essentially Chaos Monkey as a service. They have a free tier now, so you can launch CPU attacks and kill your servers using their free service. So fantastic way to get started. And then Chaos Toolkit has a bunch of resources as well, so that's available. With that, I'm going to open it up to questions. I think I might have time. At least nobody's kicking me off stage. That is my contact info on there as well, so if you think of a question afterward, hit me up on email or Twitter. And then to download these, my slides are available from the first link, and then the documents, that GitHub gist is the second one in case you want it. That said, I'll stick around up here. Feel free to come up and ask me questions. I'll be around until someone kicks me out. Otherwise, thanks for coming. It was really fun.